준비가 약간 필요할 것 같은데 사실 저희가 좀 장소가 비좁아서 불편하실 것 같아요. 의자를 조금 더 놨거든요. 여기 앞에 빈자리하고 옆에 지금 새로 놓는 의자 쪽으로 와서 이동해서 앉아주시면 좋을 것 같습니다. 네. 이쪽으로도 의자를 좀 놔주셨으면 좋겠네요. 이쪽. 네. 잘 안 보이시는 분들은 이 앞으로 이동해 주셔도 될 것 같아요. 네.
Thank you. Thank you for having me here today. My name is Joe McGinn, and I'm on my 4th career. So I was a software engineer, and I was a lead game designer in the game industry for Activision, Walt Disney Corporation, and Ubisoft. Then I was a university lecturer teaching game design and programming. And now I'm a producer at Google in AR and VR. And I've always been passionate about following and joining in the new trend, the next technology for computing. And so now I believe that is AR and VR, and that is what has brought me to Google. So that's what I'm here to talk to you about today. But just before I start getting into the platforms, I want to talk very briefly about why Google is even in this space that we call immersive computing. Since inception, Google has had one mission, which is to organize the world's information and make it universally accessible and useful. So what does this have to do with VR? Well, about every 10 years or so, there is a big disruption in computing platform and user interfaces. We moved from the original computers, mainframes with punch cards, to teletype terminals, PCs and the widespread adoption of GUIs, to the internet and the smartphone era that we're in now. We believe that the next disruption in computing will be what we call immersive computing, which is AR and VR. And in a way, this might be the biggest disruption there has been yet. Because all previous forms of human-computer interaction improvements have been improvements in the analogies that we use to represent programs and data, like a file icon or a save icon. AR and VR are the first platforms where you interact directly with the digital world, often using the same abilities and skills that you learned from interacting with the real world. And this is one of the reasons we believe this will be the next major computing platform. This is how it ties back to our core mission of making the world's information accessible and useful. So first, let's take a look at Daydream, our mobile VR platform. So smartphone VR consists of 3 pieces: the phones, the headsets and controllers, and the experiences. For Daydream, we specifically certify Daydream-ready phones based on 3 criteria, which is high-resolution displays, high-performance graphics, and also very high-quality sensors for precise head tracking inside of VR. When we launched the Daydream platform a year ago, the first Daydream-ready phones were our own Pixel and Pixel XL. Today, we've certified over a dozen Daydream-ready phones, including popular phones from Huawei, Samsung, of course, with the S8 series, S8 Plus, the Note 8, and LG. So all you need is one of these phones and the Daydream headset to join VR. And just recently, we announced the second iteration, the newest version of the Daydream View headset. This is the version that is available now in Korea. Now let's take a little look. Oh, we don't have audio. Here, I think. Want to try? Yes. Yes. Yeah. Okay. We may not have audio here. That's okay. You don't get the full experience, but you can still see. So let's have a closer look at what's new in the latest version of the Daydream View. We have new custom lenses. They're the same kind of lenses you have in the high-end VR sets like the Oculus and the Vive. So these have a wider field of view and very, very clear, beautiful images. We added an additional adjustable strap to the top of the headset to make the fit more stable and comfortable. We also improved the natural fabric material of the headset, which increases comfort, and a new heat sink on the front so that the phone runs cooler. As you saw in the video, this is shipping now, this is available now in the Daydream app, is Chromecast support. So you can share your VR experience with family and friends. With YouTube, you can co-watch movies together in your virtual cinema. And we've just announced and actually shipped in 4 new territories in France, Spain, Japan, and of course, Korea. So Google knows a bit about software development tools, and we've been investing heavily in tools to make it easier for developers who are new to VR. Now, VR is about a kind of a magical experience that players and developers call presence. It's basically about fooling your brain into the believing that you have been taken to another time or place. And to achieve presence, you need to do 3 very specific things. You need very high frame rate, believable 3D audio, and natural controls. And we've developed tools to help you in each of these areas. In the real world, there is effectively 0 latency. This is what your brain expects to see and interprets as real. And there's been a lot of research into the latency between when your head movements and when your vision system expects to see a response. And basically, it has to be less than 20 milliseconds. So if you're in a VR headset and I move my head, the simulation has to respond every 20 milliseconds or faster. Otherwise, your brain just won't accept it as real. So there are 1,000 milliseconds in a second. 1,000 divided by 20 is 50. So 50 frames per second is a theoretical minimum for VR experience to work. Daydream apps are required to hit 60 FPS. It's a little bit more comfortable at 60. And so we've launched tools like the Daydream Renderer for Unity, custom renderer solution, which has features like per pixel lighting, dynamic lighting, and single pass rendering to help you have beautiful graphics that also meet the performance. We have a tool called Performance HUD, so you can see within VR how your app is performing, not only in terms of CPU load and GPU load, but also thermals. Because the device is enclosed in a case, in VR you do have to optimize for heat as well as speed. We've just announced our new audio platform called Resonance. We believe this to be the best multi-platform audio platform in the world. You can use it for all your Android, PC, and Daydream applications. Resonance simulates sound the way that the human ear and the environment works. So for examples, one of the features is called interaural time differences, which means that depending on the 3D position of a sound in the real world, it takes a different amount of time before it hits the left ear or the right ear. You don't know it consciously, but it makes the sound feel more realistic. We have what we call a reverb engine, so we can support the direct positional sound from the event to your ears, but also the second and third order reflections of the sound bouncing off of everything in the environment. You can tag the particular type of surfaces, whether it's a wooden floor, carpet. And unlike some implementations of reverb, which are what I would call a shoebox implementation, in Resonance, you can actually bake your geometry inside of Unity so that your sound is being reflected realistically off the actual shape of the environment that you're in. Resonance supports occlusion, which is sound waves that are blocked by something between the listener and the sound. Sound also has direction. So if you're standing behind a guitar player, it sounds different than if you're standing in front of them. And so we built a tool that simulates this. As well, we've also implemented Ambisonics. This is a technique that allows sound to sound not only as if it's in a horizontal plane positionally around you, but above you or below you. And the team has used Ambisonics to combine the sounds in a way that allows to support a very large volume of sound sources without hurting performance. Because there's no point in having great audio if it circumvents the first requirement for presence, which is great frame rate. Let's see how the audio is working here. I'm not sure if we can hear this or not. Maybe I can turn it up.
If we use the HTML, the sounds volumes that are, and so we ask the operator, sounds volume up.
It's okay. We're very quiet. We can. That sounds better.
이게 HTML 어린이랑 요가가 틀려서 잡아줘야 되는데 사운드가 안 나.
So if we can get this working here, all of this is sound that's being played on a Pixel device. This is all recorded from a live device. Actually, if you have a Daydream headset, you can also experience this yourself. There's an app called Audio Factory, which is the sample app from which this video comes from. You can download it from the Play Store and experience it on your Daydream View.
안 되면 그냥 가시죠. 네, 죄송합니다. 저희가 화면을 HDMI로 연결을 했는데 보통 그렇게 연결을 안 하다 보니까 HDMI로 화면을 보면서 사운드는 또 저희가 원래 사운드 라인을 따로 빼서 쓰거든요. 그래서 지금 거기 그것 때문에 연결이 원활하지가 않아서 안 될 것 같아요. 네. 죄송합니다. 이게 저희 노트북이 아니고 직접 갖고 오신 걸로 연결을 해야 된다 그래서 저희가 해드렸는데 저 화면이 안 나오는데.
Thank you. That's okay. You'll have to try it yourself on the Daydream app. It's okay. Thank you. The third requirement for presence is natural controls. I was speaking with Alchemy, the developers of the renowned VR hit Job Simulator. They told me about in the early days of VR development, before there were motion controllers, there would be these epic Reddit threads of the VR developers talking about how they'd achieved presence for 30 or 40 seconds. What an accomplishment this was. Then they got the first motion controllers from Vive and were amazed to discover that suddenly presence was free. People could have a great sense of presence. So interacting with the world with our hands is so natural and ingrained to us that this is the final piece that makes presence work. So Google has created this set of tools called Daydream Elements. So these are open source, Unity-based elements that you can use in your apps to get started that solve some of the more difficult problems for new VR developers, such as a teleportation solution that won't make the user uncomfortable, the Unity renderer that I mentioned earlier, UI features like swipe menus and constellation menus. But relating to controls, object manipulation, and something we call the ARM model. By using the controller like a laser pointer, our object manipulation feature has not only hinges, but supports a simulation of mass and weight, so that you can actually feel the pull of the door or a heavy object when you pick it up. And then the last piece we have for controls is called the ARM model. So the Daydream controller is what we call a 3DOF, or a 3-degree of freedom controller, which means it has accelerometers. Think of it like a Nintendo Wiimote. All right, it can rotate, it can detect sudden movements, but is not positionally tracked in space. That would be a 6-degree of freedom, or a 6DOF controller. So our engineers implemented a mathematical simulation of the arm and its restrictions and how it can move. So how the shoulder joint can rotate, how the elbow can move. So what they do is then they translate the 3DOF movement into a facsimile of 6DOF movement. So that if the controller moves like this, well, they assume you're holding it. Based on how the arm moves, they move it like that. And you can adjust all the variables of the ARM model to create custom ARM models like this one that is designed for swiping motions. We've created a bunch that are included. But what you're looking at here is actually the development tool. So the way you adjust an ARM model is actually the easiest way is to go inside VR, look at yourself in a mirror, and you have a panel beside. You can adjust the parameters and then just directly see what are the results. So that's Daydream. That's one of the immersive computing platforms. The other one is augmented reality. So let's take a look at AR Core. Today, there are over 2 billion Android devices active in the world. the world's most popular smartphone platform. So anything you want to scale to a large number of users has to be done through smartphones. Google has been working on augmented reality since 2014 with our Tango platform. Tango was a set of hardware sensors added onto an Android phone that allowed us to do high quality AR with the phones that were available at the time. So it adds special cameras and infrared depth sensors. Now, with the phones that we have today, it has become possible to do the same kinds of features in software. So that is what AR Core is about. It's about taking everything we learned about augmented reality in Tango and moving it to a software platform so that we can scale out to much larger numbers of users in Android devices. So the developer preview, which is available now, runs on Pixel phones and the Samsung Galaxy S8. There's actually quite a technical process that we do with each model of phone in order to calibrate it between the camera and the IMU, the inertial motion unit on the phone. That's how augmented reality works. So one by one, we're working with all the OEMs to get their phones working. So when AR Core launches later this winter on the Play Store, there will be 100 million AR Core enabled devices in the world. And in Korea, there's a special opportunity. Because Google has very strong relationships with many OEMs, but in particular Samsung and LG, and so we're working with them to enable as many of their phones as is possible. So of those 100 million users in the world who will have AR Core, approximately 10 million of them are in Korea. So actually the highest density and per capita availability of AR Core users will be right here when we launch with the first version of the app. So there's three main features that will launch with AR Core 1.0, and you can experience them all now in the developer preview. There's motion tracking, so that's full 6 degrees of freedom motion tracking, indoors or outdoors throughout your space. As you move, it will keep track of your position. Allows content to feel like it's embedded in the world. An important part of AR is understanding of the world. And the first part of that will be included in AR Core 1.0 is plane finding. So being able to find any horizontal surface, such as a table or a floor, on which you can place AR content. And the third feature is light estimation. So AR Core estimates the average light in the scene and provides that information so that you can adjust the lighting on the model. This makes the model fit much more naturally to feel like it's part of the world. Now we will look to developers such as yourselves for the real innovation. That's where the innovation always comes from on any platform. So these are just a few of the obvious early use cases for AR, just a few of the ones that we've seen working already. Of course, there will be entertainment and self-expression applications, just putting AR content in the world for fun. We have many partners already working on e-commerce applications. So this allows you to take a real-world object, place it in your business or home, move around, the 6-stop tracking, see how it fits. Do you like the color? Do you like the shape? No, you can swipe through to other objects until you find something you like. Click on the buy button, it will show up tomorrow if you're in the US, probably today in Seoul. I think you have much even faster shipping. The other element that AR Core knows about the world is scale. So fairly accurate measurements are possible. And this also means if you display a character or a piece of furniture in the world, it is displayed in a real scale. So we have one partner, for example, that is using AR for shopping for luggage, like suitcases. Actually, I had to buy a new suitcase just a couple weeks ago. I had to do it the old-fashioned way, which was measuring my cupboard space very exactly where we need to store it, because I live in Singapore. So we have small apartments, just like here. But in the future, very near future, I'd just be able to put my camera up and say, oh yes, this one fits, bye. And of course, there are countless opportunities for education and entertainment. This is a shot of Into the Wild, an AR experience that we made in conjunction with Media Monks in the Arts and Science Museum in Singapore, where we put a rainforest inside the museum. It's pretty easy to get started. You can do the developer preview today. You can add AR Core to existing Java apps. Or if you're going with developing a new AR first app, we'd recommend using a 3D engine, such as Unity or Unreal. We've also been experimenting with AR on the web browser. So we implemented an experimental set of AR Core support on top of the WebVR 1.1 API. And we've open sourced this project on GitHub. The link is here, if you're interested in experimenting with AR on the web. So you can just go to the website here, choose your development environment, and it's very easy. You can get up and running with your first AR app in a matter of hours. One question we often get, especially from engineers, is, well, where do I get the content? AR is a 3D world, right? So how am I going to get, I'm not an artist, where are we going to get the 3D content to populate this world? So we have a couple services that enhance AR that we've announced recently. Blocks and Tilt Brush you can use to easily create simple 3D content for the world. We've also announced our Poly platform. So even if you don't even want to create something in blocks, there is already a large library of 3D content on Poly that you can download to use in AR or VR. Much of which is open source library, freely available for you to use. And we just announced last week the Poly API, which allows you to integrate the Poly library into your apps or your services. So you can, from your services, directly download the content into your whatever environment or apps you want. And just one more quick video we're going to look at. So this was just what Google engineers were able to develop in just a few short months that we've been working with AR Core. Thank you.
네, 감사합니다. 질문이 하나가 올라왔네요. 혹시 대신 질문을 해주실 분 계신가요? 질문 내용은 VR 기기 이용 시에 좀 더 답답하지 않고 가벼운 제품이 나왔으면 좋겠는데요. 영화 마이너리티 리포트에 나온 것처럼 AR과 VR 결합은 개발하기가 힘들까요? 이거는 우리 전진수 랩장님이 답변해 주셔야 될 것 같은데. 네. 이거 좀 띄워주시겠어요? 질문을? 지금 질문을 올려주셔도 됩니다. 앞에 그 박진영 원장님 발표하실 때 질문 올라왔던 것 같은데 두 건은 오후에 저희 조성호 랩장님 5G 발표하실 때 제가 같이 여쭤보는 걸로 하겠습니다.
So the question is that the headset, VR headsets can become a little bit heavy or maybe uncomfortable after a long time. So the question is it possible to integrate VR and AR, kind of like Minority Report? And the answer is yes, definitely. If you don't believe me, you can go right out here and see the SKT platform. They actually have one of the best examples I've seen of that yet, of a solution where you can be in AR, like looking at, say, a building. You can go into VR mode, which is using AR, but then walking around as if you're inside the building. And so that's another way you can get like a VR kind of experience, see the inside, you know, turn on the TV, you can watch TV inside your augmented reality, virtual reality experience, or transfer it into a full VR helmet. The one other thing we're trying to do to increase user comfort is actually to make VR easier and quicker and faster to get in of or to get out of. So in the new year, we will be launching a standalone headset. Does not require any phone or PC. Everything's just built into the headset. And one of the things that I've experienced with the dev kit at the office is actually I'm more likely to go into VR just because I don't have to go through that process of putting the phone in and plugging my headphones in and I just pick it up and put it on. So it's as frictionless to use as, say, Google Cardboard, maybe more so, because again, you don't even have to put your phone in.
Thank you. Another question. If you develop hardware for AR, any special hardware for AR you developed?
I'm not sure I understand.
Hardware for AR.
Like they're asking if they
Yeah.
can develop or if we have developed.
You developed the hardware for AR service, AR service.
They are asking about the hardware status for AR devices. AR devices, hardware status.
The hardware for AR.
So, like, I think they are questions about the glasses.
Like AR glasses, they want to know are these coming?
Status.
Like AR,
Market
like
status.
AR
Yeah,
headsets?
not just for your side, market status.
Okay.
AR glasses, AR devices.
Okay, so I think the question is asking kind of about the market status of AR, where we are from moving from, mobile to glasses, and so on, right? And it's a pretty hard question to answer in the short term. I'm completely convinced. I can easily answer the long term. 10 years from now, it'll look like this, right? Or maybe even contact lenses. You'll put on your glasses. And okay, now I can put 3D content in the world. That's what we're moving towards. That's what we really mean when we talk about this immersive computing platform, that is something that easy and that natural. Right now, in terms of wearable AR, we're very much in the we've proved it. There are different companies that have proved it can work, but not really at a very usable level. And some of this is due to cost reasons, and some of it is due to more annoying inconveniences such as physics. So the HoloLens, for example. HoloLens actually have a lot of respect for. I'm very impressed by what Microsoft has done with the HoloLens. It's a really great proof of functional concept of what these glasses will feel like in terms of function 10 years from now. But it's a little bit uncomfortable, not only in terms of the weight of it, it's heavy, but these things will change. But the field of view is very, very small. Kind of like looking through a cardboard tube like you did when you were a child, right? You'd run around the house like this. And that's a very difficult problem to solve. So I can't really predict, when it's going to be solved. There's many very smart computer vision, human vision engineers working at it, at Microsoft, at Google, at Apple, at all these companies. They're trying to figure out how we get to that comfortable, usable, wearable display.
There are lots of questions. 갑자기 질문을 많이 보내주셔서 이 중에서 한 두 개만 골라보도록 하겠습니다.
That's a good question. Take the top one.
Okay.
So what is the biggest thing to be improved in hardware for AR? CPU, GPU? Probably CPU and GPU right now. So currently, it does take quite a strong CPU, in particular, and GPU, to be able to run a high quality AR experience, which is why we're working on, in our work to support existing models of phones, we're looking at two things: the install base, how many of the phones are there, but also are they powerful enough to do the calculations necessary. I think this problem will go away over the next few years, both because the phones continue to get better for a lower price. We're also trying to optimize the code as much as possible. We would like to get it down to where it can run on what might be considered more of a mid-range phone. Not going to make any promises. There's engineers working on this. So this will sort of naturally go away as we proceed, but it will take a couple years before you see really widespread of where it's just, okay, Android phones just now work with AR Core-like solutions.
Okay. How about one more?
Sure.
Okay. How about the last one? Any plan to optimize Tango system?
So all of our new development is now being done on AR Core, but we're taking what we learned from Tango and applying it to AR Core. So it's unlikely that we'll be going down the path of Tango of hardware-based solutions, just because of this problem of how do we scale to the wider, we want to be able to scale to more users, right? But we are looking at all of the features that were done in Tango, and is there ways to do them in software? Which now often the answer is yes, when it was not the case 2 or 3 years ago, in part because of improvements in machine learning. If you've seen any Google events recently, you know that machine learning first is the new belief and philosophy that guides all of Google, not just the AR, VR departments that I'm part of. And so using machine learning and computer vision, for example, one thing we've solved is, how do we know where the floor is? Just through a camera. And this is an example. The Tango phones had an infrared depth sensor, right? But there's no such sensor on the Android phones. They use machine learning to be able to learn how to interpret the data from the camera to be able to get this estimation. And so this will continue to improve. In general, knowing and understanding the environment around you is an important part of AR. And this is a huge focus for future improvements from our research teams.
오케이. 여기까지 질문을 받도록 하겠습니다. 시간이 초과해가지고. Thank you for your presentation today.
Thank you.
네, 큰 박수 부탁드리겠습니다. 네, 네, 오전부터 오셔가지고 공부하시느라고 바쁘셨던 것 같은데 저희 이제 오전 세션이 끝났습니다. 그래서 이제 즐거운 점심 시간인데요. 저희가 오늘 도시락을 준비를 했는데 좀 인원이 많지만 밖에 나가시면 이제 4줄로 이렇게 도시락을 받으실 수 있게 했어요. 그래서 오늘 그 쿠폰 받으신 걸로 이렇게 교환을 하시면 되고 그 이 자리에 오셔서 식사를 하시는데 옆에 그 팔걸이를 이렇게 젖히시면은 거기에 테이블이 나오거든요. 거기에 올려놓고 식사를 하실 수 있습니다. 그래서 이쪽에서 드시고 밖에 이제 오픈된 공간에서 드셔도 되고요. 네, 점심을 맛있게 드시고 저희가 1시에 이 자리에서 다시 모일 거고요. 여러분 1층에 내려가셔서 그 체험버스 보실 분들은 12시부터 1시까지 운영이 되고 또 자율주행 자동차도 지금 보실 수 있으니까 또 식사하시고 내려가서 한번 보시고요. 밖에 전시장에서 실제 AR, VR 체험도 좀 해보시길 바랍니다. 네, 수고 많으셨습니다.